Hello, this is a video for EDX Statistics 1. It is the second video in this series, and it will be looking at two-tailed hypothesis tests of the mean of a Poisson distribution. What's different about a two-tailed test is that rather than looking for a specific increase or decrease for the mean, a change in the mean could be either. The data, when we collect it, may suggest an increase or decrease, but before we get to that point, our question will be simply looking for either. When we carry out a two-tailed test, we'll need to look at the probabilities for both greater than or equal to our particular value, or less than or equal to our particular value. Here's an example of a Poisson distribution hypothesis test which is two-tailed. A company manufactures light bulbs, and when everything is working normally, it knows that 0.9% of all those bulbs are defective. And they want to test at the 5% level whether the percentage of faulty bulbs on a day has changed from this 0.9%. So they take a random box of 500 bulbs, and it's found that 10 of those bulbs are defective, and it wants to know whether that is evidence of a change in the percentage. So this is actually a binomial situation where n is equal to 500 and p is equal to 0.009. But because n is large and p is small, we're going to use a Poisson approximation to this where lambda is equal to np, so 4.5. As with all hypothesis tests, we're going to set up our null and alternative hypotheses. So under normal situations we have that lambda is equal to 4.5 and we're testing to see whether that value has changed. So we end up with a not equal to 4.5. We're asked to test at the 5% significance level. Now because this is a two-tailed test, the actual value we're going to compare at the end is actually 2.5%, and that's because we're splitting our critical region into two, both at the top end and at the bottom end. So here's the bottom end and here's the top end. We've actually observed 10 defective bulbs in our box, so we would consider both greater than or equal to 10 and less than or equal to 10, but there's no need to look at less than or equal to 10 as our data is suggesting that the percentage change is greater than it was before. If we'd ended up with a value of less than 4.5, we'd have looked at less than or equal to that value instead. If we were to calculate the value for less than or equal to 10, it's definitely going to be bigger than 2.5%, so we'd end up accepting H0. And we only want to look at things where there's a possibility of rejecting H0. So if we calculate that probability, either on our calculators or on a statistical package, you can see that we get 0.0171. Now, as mentioned before, we're actually going to compare this to 2.5%, and it is less than 2.5%, so we can reject H0. There is evidence to suggest that the percentage has changed. That's the end of this video. The next video in this series is about critical values and critical regions for Poisson hypothesis tests.